Welcome to the video lecture on signals and systems. So we are discussing about analysis of DT systems. This video we will learn how to calculate the output response y of n of a DT system without considering the initial conditions. So here is a question. Consider the following constant coefficient difference equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 equal to 2x of n minus 1. Determine y of n when x of n is equal to del of n and y of n is equal to 0 for n less than 0. So from the given questions, it is understood that they have mentioned it as y of n is equal to 0 for n is equal to 0, which actually implies that the initial conditions are 0 in this case. So we will take Z transform on both sides. So we have a difference equation here. So we have y of n. When we apply Z transform, y of n becomes y of z. Y of n minus 1 becomes z inverse y of z. Y of n minus 2 on Z transform becomes z power minus 2 y of z. And x of n minus 1 on Z transform becomes z inverse x of z. So when we apply Z transform on both sides, we get 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2 y of z equal to 2 z inverse x of z. X of n is actually del of n given in the question. So what is x of z? 1. Del of n on Z transform gives you 1. So let's substitute x of z in the previous equation and we get it as y of z equal to 2z inverse by 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. So let's convert everything to z and we get it as 2 by z square minus 3 by 4 z plus 1 by 8. So next step is to get the partial fractions. So for partial fraction, what do we actually do? We bring it to the form of y of z by z. So we will have to, so since we already have a z inverse in the numerator, we just bring it to the other side, to the denominator, and we get it as y of z by z equal to 2 by z minus 1 by 2, z minus 1 by 4. So this is nothing but a1 by z minus 1 by 2 plus a2 by z minus 1 by 4. So we bring it to the partial fractions form, 2 equal to a1 z minus 1 by 4 plus a2 z minus 1 by 2. So substitute z is equal to 1 by 2 and a1 is equal to 8. Next, substitute z is equal to 1 by 4 and a2 becomes minus 8. So substitute the values of a1 and a2 in the previous expression and we get it as y of z equal to 8 z by z minus 1 by 2 minus z by z minus 1 by 4. So let's take inverse Z transform of the same. So what is the inverse Z transform? Generally a power n u of n on Z transform gives you z by z minus a. So this is of the same format. We have it as z by z minus a. This is also z by z minus a. A in this case, first term case is 1 by 2. A in the second term case is 1 by 4. So we'll have to put it as a power n u of n. So y of n is equal to 8 1 by 2 power n minus 1 by 4 power n u of n, and ROC is z, modulus of z greater than 1 by 2. Next problem is y of n plus 2 plus 1.1 y of n plus 1 plus 0.3 y of n is equal to x of n plus 1 plus x of n, where x of n is equal to minus 4 power minus n u of n. Find y of n if the initial conditions are 0. So here it is directly mentioned in the question that the initial conditions are 0. So we will directly apply Z transform on both sides. So what do we get? We have it as y of n plus 2. So generally y of n plus 2 on Z transform will give you z squared y of z. If it is y of n minus 2, then that will give you z power minus 2 y of z, as we saw in the last problem. So this becomes z squared plus 1.1 z plus 0.3 common y of z, which is equal to z plus 1 x of z. Given x of n in the question is minus 4 power minus n u of n. So this on Z transform gives us x of z is equal to z by z plus 1 by 4. So let's substitute this x of z in the previous expression. and we get it as y of z is equal to z into z plus 1 by z plus 1 by 4 z square plus 1.1 z plus 0.3. So this second term on factorization gives us z plus 0.5 and z plus 0.6 to the denominator. So next what we'll have to do is we'll have to take partial fractions. So for partial fractions we need it in the form y of z by z. We already have z in the numerator. So just cross multiply that to the denominator on the other side. So now we get y of z by z equal to z plus 1 by z plus 1 by 4, z plus 0.5, z plus 0.6. So this we make it as a1 by z plus 1 by 4 plus a2 by z plus 0.5 plus a3 by z plus 0.6. So you substitute z is equal to minus 1 by 4 to get a1, z equal to minus 0.5 to get a2, and you substitute z equal to minus 0.6 to get a3. So doing so, we get the a1 value as 8.57, a2 value as minus 20 and a3 value as 11.3. Let's substitute each of these numerical values in the previous expression and you get it as y of z is equal to 8.57 z by z plus 1 by 4 minus 20 z by z plus 0.5 plus 11.43 by z plus 0.6. So we'll have to take direct inverse z transform. We very well know that a power n u of n on z transform will give you z by z plus a. So using that we have z by z plus 1 by 4. So the first term becomes 8.57 minus 1 by 4 power n. Look at the second term, z by z minus 0.5. So this becomes minus 20 minus 0.5 power n u of n plus the third term we have z by z plus 0.6. We'll have to have an z here which is actually missing. So this is 11.43 z by z plus 0.6. So that we get it as 11.43 minus 0.6 power n u of n. So we'll take u of n as common and we have the answer here. So this is a question where impulse response has been asked to solve. A causal LTI system is described by the difference equation y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. So for this you will have to find the system function for the system and you will have to find the unit impulse response of the system. So first we will take Z transform on both sides. So taking Z transform on both sides, we get it as 1 minus Z inverse minus Z power minus 2 y of Z equal to Z inverse x of Z. So what is h of Z? Y of Z by x of Z. So bring it to the form, just cross multiply and you get it as Z inverse by 1 minus Z inverse minus Z power minus 2. This is the system function of the system h of Z. Next, you will have to calculate the impulse response. So just transform these h of z to positive powers of z. So we get it as z by z squared minus z minus 1. For taking partial fractions, we need to have it of the form is h of z by z. So we already have z in the numerator, just cross multiply to the denominator on the other side. We get it as h of z by z equal to 1 by, just factorize the denominator. You get z minus 1.618. Z plus 0.618. So this we have it as a1 by z minus 1.618 plus a2 by z plus 0.618. You substitute z is equal to 1.618 to get a1, which is 0.447, and you substitute z equal to minus 0.618 to get a2, which is minus 0.447. So substitute the respective values of a1 and a2 in this particular previous equation and you get your h of z as 0.447 multiplied by z minus 1.618 minus z by z plus 0.618. So apply direct inverse z transform and you get h of n is equal to 0.447 1.618 power n minus of minus 0.618 power n u of n as common. So this is nothing but a power n u of n on z transform gives you z by z minus a. So the inverse we have applied here. Thank you.